influence on my life and getting to where I'm at today at JPL, and I thank him for that.
Yeah, my father is from Bolivia, so I understand what you mean when you say that work ethic is so strong, and I'm sure they're really proud of you right now. Ed, can we kind of get more into what you studied at school and your path to JPL?
Yeah, well, so I went to Arizona State University where I graduated with a bachelor's in electrical engineering. I eventually got a master's in business from University of Redlands. But when I was in school at Arizona State University, I also started working part time as an academic part time for Honeywell Aerospace. There, I was working, you know, near full time, about 30 hours a week, plus taking a full load at ASU. And in doing so, I was able to, help pay for my college and get through that. But then I eventually, started working for them after I graduated. However, I still really had, my what do I want to do? Like, I really want to be in aerospace. That's been a big passion of mine, growing up. And so I started looking for work outside of Honeywell and in the aerospace area. And I found a company in Pasadena that turns out was a contractor to JPL. And so I interviewed with this company and, obviously got hired. And then I moved to Pasadena and was working for JPL as a contractor. And my first job through this contracting company was working on the Mars exploration rover, Spirit and Opportunity, and building and working on the schematic captures for their rover electronics module. And that was something that started off my career. Ever since then, I've been on Mars Science Laboratory, the Dawn spacecraft, now Mars 2020, and I've been here over just about 20 years now. It's been quite a ride and quite an enjoyable ride at that.
Wow. So is this your favorite mission so far, you'd say?
Yeah, I think they're all my favorite, but yeah, this one has been a challenge, right? From working on the sample caching system, developing a robotic system, to capture samples on Mars has been outstanding, and I think it's been more just the team environment that we've been able to build, within both tasks, both the sample caching and the system testbed. I get a chance to work with a lot of incredible, talented engineers, and we're able to really come together and get this thing going. So, yes, I think that's what makes this one of my favorite projects that I've been able to work on.
And you were kind of mentioning that troubleshooting is a big part of your job. So what kind of hurdles have you had to overcome when you're testing?
Yeah, so troubleshooting, testing, finding problems, that's exactly what I live for when I work on these missions. The idea is that if we can flush it out here, we can fix it, we can mitigate it, we can get it ready to go so that when we get to Mars or our final destination, we would know, we have confidence that this thing is that our spacecrafts are going to work. And so one of the issues that I'll bring up that we've had recently, or over the time with developing the sample caching system, is within the robot is in the drill. On the drill, we have these ball lock mechanisms that are used to hold the drill bit in place as it, sort of as a gripping mechanism. Now, when we're working with rocks, you're going to have fine powder, and as you're drilling into the rocks, you're going to have this fine powder. Well, this fine powder kind of can get and creep into crevices. It's almost like when you go hiking and you start walking the trails, and you start to kind of climb higher and higher into your mountain trail. You start to find out that your hiking boots might actually get a little bit caked of some of this finer dust as it kind of sits in there and gets in these crevices. Makes it for your shoes to be a little slippery. So what you do is before you go on a narrow part of the hike or of the trail, you're going to tend to kind of kick your shoes a little bit and get that dust off. And that way it gives you a nice clean grip, and you're back to where you wanted it to be with your shoes. So imagine the same thing where you have this powder that's flowing as we're interacting with rocks, and you got a dusty and Mars environment. We have this really fine powder, dirt that has been, kind of being pushed around and circulating around the drill as we're operating it. While this powder is getting into some of the crevices around the ball locks, which is not letting them move as freely as we like. So during one of our tests, we were trying to go and pick up a bit, and we were unable to get past the ball locks. We eventually can show that if we push on it hard enough, it'll work, but we want to understand why were the ball locks not free as we would have liked them to be. So, we're able to break our chamber, and break the chamber open and go and take a look inside. And as we look inside, we notice that there's this fine powder material around the ball locks. And we realized that, well, we have a mitigation plan already that we can employ. One of which is we call the percussive cleaning. When we get to Mars, one of the early things that we're going to do on the surface is to get the drill and do a percussive cleaning, which is using the hammer that's built into the drill to sort of shake loose any loose particulates that may have traveled with us from Earth to Mars, and get it off the drill before we start trying to do any sampling. So we decided that we're going to use that similar approach on the drill to help clear out any of this fine powder from these ball locks. And once we did that, we're able to get the ball locks to actually operate back into I'll say a clean state, and they moved freely again. So it was something that we discovered here because we needed to really interact with the rocks to see it. And it's now something in our repertoire to fix or to use while we're on the surface to help mitigate this issue.
And someone on social media actually has a really good follow-up question to that. Abdul on Facebook wants to know, is the Martian ground sand or clay?
It's actually a mixture, right? So there's actually a wide range of types of rocks that we interact with. There are clays for sure. There are some mudstones, which is more like a clay. Harder rocks. We also have regolith, which is just like a sand consistency that you might see. So we actually have a wide range of rocks that we have to be able to interact with and to take samples. So we've actually developed algorithms to ensure that we don't break the samples up too much as we're trying to take a core sample. So depending on how hard or soft the rock is, we'll change our spindle and our percussive frequency to adapt to the varying types of rocks that we might interact with.
And Tracy on Facebook wants to know more about the samples. She wants to know, will Perseverance actually bring samples back to Earth?
Right. So Perseverance is not the return mission. So our job is to actually go and collect the samples, whether it's a regolith, a sand material, or actual rock samples. Once we actually take the rock sample out of the ground, we'll then hermetically seal the tube. The tube will eventually be dropped off at a site where a future mission would be able to come and pick it up and potentially bring the samples back. But our job is to actually collect the sample and keep it hermetic and make it hermetically sealed for a future mission's return.
Then Emily on Facebook wants to know about that. Will the collection techniques for Perseverance on Mars be similar to the way OSIRIS-REx sampled Bennu?
No, it's a little bit different. So we're actually taking a coring drill to go up to about 70 millimeters deep into a core, into the rock, for instance, right? So we're actually planning on taking core samples out of the ground, whereas I think in OSIRIS-REx, it's more of they do some ingestion of the sand around them where they landed, and it's more like a contact science there. Ours is to actually, we will do some science ahead of time so we know which rocks we want to pick up and sample, but we're actually going to go in and take a sample out of the ground It's probably about the width of your pinky, or at least my pinky, and about that size too, as far as how much sample we're going to get out of the ground.
Huh. Never thought of it that way before. And thank you, Emily, for keeping track of several missions at once, too. And now we have Sandy on Facebook asking, what will we be able to learn about the samples collected prior to bringing the samples back to Earth for further study?
So we have a couple different instruments that will be doing X-ray spectroscopy to actually determine what sort of content might be in those rocks, right? So the idea is that we're going to go around and we are going to look, at different rock samples. Now, right, rocks may have different shapes and may look a little bit different based on where they're at, but some of the chemical composition may be the same between rocks that look different. So the idea is that we're going to actually go ahead and we will do potentially an abraded patch first, where we might clear off some of the initial, I'll say, the weathering that's happened on Mars over the time, and get down and make a judgment on whether or not we actually want that rock. So the scientists have a whole collection of instruments that they're going to use to pick up, decide which rocks they want to bring home.
And then this one is from Mike Kiki, and it kind of goes back to what we first touched on. They ask, did you always have a love for jet propulsion and or the aerospace engineering industry?
So I'll be a little embarrassed on this one, right? I think my initial love was aerospace because I didn't know that the jet propulsion existed in the way it does today, right? So now that I'm at JPL, it's, by far this is where I want it to be, nowhere else, right? So this is one of those things where, I just didn't know. I was not as keyed into, the different centers and what everybody does, but the work that we do here, our ability to be hands-on and work and design and build and get your hands dirty, that's what really makes it for me. So so I, as much as I'd like to say JPL was always my go-to, my number one, I just wasn't aware of it when I was first getting out of college and looking around. So so I guess aerospace, but JPL opened my eyes to how fun this work could really be.
It's okay admitting that you didn't know. Lots of kids that are watching right now might wonder, how do you get involved, or how do you learn about the different types of engineering that's involved in the industry?
Well, I mean, the thing is, there's probably every type of engineering that you can imagine and science is part of JPL. I know that I've talked to people that develop software, electrical engineering, of course, mechanical engineering, aerospace, chemical engineering, from, chemists to physicists. I think we probably hit the range. I don't know that there's an engineering discipline that you can probably ask, is this one that's relevant to JPL? Then we'd say no, because we do rely on outside, thinking out of the box and bringing in outside, I'll say, views into solving some of these problems. They're not all just kind of black and white and are purely mechanical, purely electrical. There's robotics. I mean, it's all over the place. And so I don't know that there's a bad engineering. It's more making sure you do something that you really enjoy, because that's where, when you really enjoy what you're doing, that's where the work really shines. And that's where we're able to really show that, how exceptional our work can be. Because I think everybody that does the work here really enjoys, their engineering, and they have a passion for what they do.
And then Nabil on YouTube wants to know, how did you develop your soft skills?
Oh, a lot of trial and error. It was, I've had to, work with teams, right? We always work with teams. We work as a fairly large, community of engineers working to get things through, and over time, I've made my mistakes, and maybe come down a little too hard on somebody, or vice versa. And so I've learned, and I try to learn from other managers that I've worked for. I